some shortcuts. So let's see, today we are in section 4.3, and I'm going to just call this more congruent triangles. So we talked about a couple of shortcuts for triangles. We said that we could use for triangles side, side, side. So if we could show that three sides of one triangle are congruent to three sides of another triangle, that showed that the triangles were congruent. And we also talked about side, angle side. So if we had two sides and the angle between them, we had to be careful that the angle was between the two sides, congruent to the two sides and an angle between them on another triangle if the triangles were congruent. Does anybody remember what special word we used for that angle that was between them? We came up with a vocabulary, we had a vocabulary word for that. Remember what it was called? Included. We call the angle the included angle. So when you see included, what included means here is it's between, really. So we have another, we're going to talk about two more ways that we can show that triangles are congruent. Our first new way today is called the ASA, and that is on your graphic organizer in the upper right. ASA is angle side angle. And so far all of the ways that we've talked about to show that triangles are congruent have been postulates. So we're talking about postulates. These are things that we accept as true without proof. And what the angle side angle postulate tells us is that it's like the side angle side, but just kind of in a different order. If two angles, I'm going to use a little shorthand here, and the side between them on one triangle are congruent to two angles and the side between them on another, then we know that the triangles are congruent. And just like we did with the side angle side, we call this the side that's between the two angles is the included side. And if we want to draw our picture on fill in our picture, mark our picture on our graphic organizer, picture looks kind of like this. And for side angle side, our triangles would be marked, or sorry, angle side angle, our triangles would be marked like so. So the side is between the two angles. So just like we talked about on block day, our triangles match up in the way that it says in our postulate. Angle, side, angle. Angle, side, angle. So questions on angle, side, angle. Works a lot like the other ways. Just have to be careful that our side is between the two angles, but that just gives us another way to decide if triangles are congruent, just like the side, 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 and side, angle, side. It's another way to show that triangles are congruent. All right, so let's go to our next box. But I want to, before we fill in our next box, I want to talk about a mistake that students make often. And I'm going to write this in red so we don't make this mistake. I'm going to say AAA doesn't work. So angle, angle, angle can't prove that triangles are congruent. So you might want to put a little note in the margin of your graphic organizer, something like that. So we can't use angle, angle, angle to show triangles are congruent. I'm going to draw a picture that hopefully will help convince us that that's true. Here's one triangle, and I'm going to draw another one. There are two triangles with all the angles the same that are not congruent. So they're the same shape, but they're not the same size. So the angles in these triangles are the same, but the triangles are not congruent. So this is why angle, angle, angle can't work to show that triangles are congruent. It doesn't guarantee that the triangles are exactly the same. Later on in second semester, we will talk about what does happen when triangles are the same shape but not the same size. It's another kind of special set of things that happen with these triangles. So angle, angle, angle doesn't work to show that triangles are congruent. All right, let's look at our next way now that we can show that triangles are congruent. And this one's a little trickier. We're going to look at angle, angle, side. So this part doesn't go into your graphic organizer yet. So I want to talk a little bit about it first, and then we'll add the information to our graphic organizer. So let me draw a triangle, and we will talk a little bit about this triangle. Let me draw another one. So there are my two triangles, and I know that this is 60 degrees and this is 75 degrees. I'll draw 5 today. And this is 60 degrees and this is 75 degrees. And I know that this side is congruent to this side. Well, from what we've learned so far, we don't have angle, side, angle. And we don't have side, angle, side because we don't know this side and we don't know this angle. But what did we talk about the other day? That we talked about something that happens when we know that two angles of one triangle are congruent to two angles of another triangle. What do we know about that third angle?
It's going to add up to 180.
They have to add up to 180, right? So what is true about the other angle, Matt? The other. So what do we know about these two angles? They have to be congruent. So if I add 60 and 75 together and subtract it from 180, that tells me that this angle has to be 45 degrees. Same thing on this triangle, because they have to add up to 180 in both triangles. Well, now, what could I say shows these two triangles are congruent. I'm going to have an angle, a side and an angle, and the sides between the angles. So I could say these are congruent by angle, side, angle. But we started out with an angle, angle, side. So this kind of leads us to our angle, angle, side theorem. And this is where we have to be careful about how we use angle, angle, side. So the angle, angle, side tells us, and this is our theorem because it comes from side, angle, side, angle. So we're going to say if two angles and a non-included side so our side doesn't have to be between the two angles for angle, angle, side. Are congruent to the corresponding, I'm going to stop here. What did we say corresponding means? What is it, Rand? They go together or they match. So if two angles and a non-included side are congruent to the corresponding angles and side on another triangle, then the triangles are congruent. And the important part here, the extra little detail is this corresponding. We have to make sure that the parts are in the same order. And we have to make sure they match up. So with angle, angle, side, we're going to say the parts have to be in the same order. So with angle, angle, side, we have to make sure that the parts match up in the right way before we can use it. If they match up in the right way, then what happens is exactly what we showed in this example. The third angle has to be congruent, and then it turns into an angle, side, angle. So if we can match up the parts in the right order, we can shortcut and not have to figure out that it's an angle, side, angle combination. So I want to look at some practice problems where we're trying to decide if we can use angle, angle, side. Does anybody have any questions about what we're talking about with this angle, angle, side triangle? All right, so let's look at some examples. And these we're just trying to decide. Can we use angle, angle, side on these triangles? So we're going to use a bunch of examples. Look at a bunch of triangles here. So here is one pair. And I'm going to say that this is 45 degrees. This is 60 degrees. 45 degrees on this one, 60 degrees on this one. Looking good so far. And I'm going to say that this side is 3 units and this side is 3 units. Thank you. Oh, that you were in here? Okay. All right. Let me do this really quickly. All right. So can we use angle, angle, side here? We have 2 angles that are congruent and a non-included side that are congruent. Okay. Ashley says no. Why not? they're not in order, right? The side that's length 3 is by the 45-degree angle on this triangle, and the side that's length 3 is by the 60-degree angle on this triangle. So the parts don't match up. So we're going to say no, not in the right order. They don't match up the right way. Let's look at another one. And again, with these kinds of pictures, remember to go by what the diagram says, not by what they look like. So even if the angles don't necessarily look congruent, whoops, I'm wanting to do I got to go backwards here a little bit. There we go. How about with this combination? Can we use angle, angle, side here? We think yes? Angle, angle, side. The side that's congruent is next to the angle with 2 tick marks. So everything matches up in the right order. If I move this triangle over here and put it right on top of this one, all the pieces would match up in exactly the same way. So we can say yes, this would be a angle, angle, side triangle. Let's look at another one. Here are my triangles. I'm going to mark them this way. How about this one? The side with the congruent side is next to the angle with 2 tick marks on both triangles. So this one works out okay, right? Got a couple of people saying no, a few people saying no. Still not in the right order. So this one we have an angle side angle triangle, and here we have an angle angle side triangle. So that even though that this is next to the angle with 2 tick marks, it's still not in the right place. So this would be a no. And let's look at one more. Here are my triangles for this one. How about these two? Evan says yes. Maddie says yes. Pam says yes. So what do we have to do to these 2 triangles to even though this side looks like it's facing the other way, what can we do to this one to match up with that one? Or what I have to do? I have to flip it, and flip it over or reflect it, and then it would match up exactly. So the side with 1 tick mark is right next to the angle with 1 tick mark, and it's in the right place. So this would be a yes, this one works. Or an angle angle side. All right, let me do, I know I said one more last time, let's do one more. I want to try to make it a little trickier. How about that one? Ashley says no right away. You guys are good at making these match up. So this one, the tick mark is next to the side with one tick mark is next to the angle with one tick mark, and here it's next to the angle with two tick marks. So this one would be a no. We could not use angle, angle, side to show that those two triangles are congruent. So questions on those examples? So really the important thing with angle, angle, side is we have to make sure that the things match up in the right order. For angle, side, angle, side, we have to make sure the side or the angle is between the side or the angle between the two sides or the two angles that we're matching up. So that's with angle, angle, side, we have to be a little more careful. All right, the last thing I want to do for today is do a little proof using angle, angle, side. So just so you can see what I want to, we'll do proofs just here and there as we go on, so you see how we do them, and hopefully we get better at doing them. So here is our picture. And I'm going to draw this diagonal. So, say that those two angles are congruent, and I'm going to put these arrows. What do the arrows tell us? It tells us that those two sides are parallel. And I'm going to call this polygon A, B, C, and D. So here's what we're given. We're given what we're marked here. So we're given that angle ADC is congruent to angle CBA. And we're given that side AB is parallel to side DC. We want to prove that triangle ADC is congruent to triangle CBA. So we want to prove that this triangle is congruent to this triangle. So we'll do a two-column proof. Our statement and our reason. So I'm not going to rewrite our given. A lot of times the given will be rewritten. But we're going to say that we know that these are given. All right, so how does the fact that these two lines are parallel, how does that help us here? What can that help us figure out? When we have two parallel lines, here are two parallel lines. This is our transversal. So for congruent triangles, what kind of things do we need to figure out that are congruent? Angles. Would two parallel lines cut by a transversal, do those have anything to do with angles that are congruent? Okay. So that's how it might help us. So let me mark a couple of angles here. I'm going to mark this angle and this angle. What kind of angles are those? Are those the ones that I want to do? No, those aren't the ones I want to do. I want to do this angle and this angle. There we go. What kind of angles are those for the two parallel lines cut by a transversal? What did we call those kinds of angles? Those are alternate interior angles. What do we know about alternate interior angles? They're congruent when the lines are parallel. So I can mark these as parallel, and I can say for my statement that angle DCA is congruent to angle BAC. And we decided that's because they are alternate interior angles. All right, so now we have an angle and an angle. Is there a side there that we can show as congruent? AC is congruent to itself. So segment AC is congruent to segment AC. And what did we call that when we say something's congruent to itself, Matt? Reflective. No, you were right. Reflexive. People think reflexive, but you're right. Reflexive. It sounds like reflective. Reflexive. IVE. So this is the reflexive property. Well, what kind of arrangement do I have now for my triangles? I have angle, angle, side, and they're in the right order. So I can say now that finally that triangle, that didn't take too long. Triangle ADC is congruent to triangle CBA by angle, angle, side. And we have our triangle, our vertices written in the right order because angle C matches up with angle A, angle D matches up with angle B, and angle A matches up with angle C. So questions on that proof? So this one's kind of nice because we use parallel lines and the reflexive property to show that these are congruent by angle, angle, side. All right, so just a summary for today. Two new shortcuts for showing triangles are congruent. Angle, side, angle. The side has to be between the two angles, and then angle, angle, side. We just have to make sure that all the parts match up in the right order.